Welcome to the Tablet Formulation Masterclass. In this video, we will explain the essential concepts of formulating and manufacturing pharmaceutical tablets, based directly on your handwritten lecture notes. Let's dive in. First, let's talk about excipients. These are pharmacologically inactive substances that act as bulking bodies. Diluents like lactose add volume. Binders and granulating agents act as glue. Disintegrants expand under moisture to split the tablet apart inside the body. Lubricants prevent powder sticking to the machine parts. And glidants ensure smooth hopper flow. Next are the manufacturing granulation methods. Wet granulation uses liquid binders to form a damp mass which is then dried in a fluid bed dryer. Dry granulation utilizes roller compactors to squeeze dry powder into slugs which are milled into granules. Direct compression directly mixes and compresses highly flowable materials without wetting. Now, let's examine tablet compression. In a single punch machine, the hopper shoe moves forward to deliver granules into the empty die. Next, the upper punch descends, applying high pressure to compress the granules into a solid tablet core. Finally, the upper punch ascends. The lower punch rises to eject the finished tablet, and the shoe sweeps it away. Tablet tooling follows standardized B and D classifications. A typical punch consists of a head, neck, barrel, stem, and tip. D tooling has a large 1-inch barrel for heavy force and big tablets, whereas B tooling has a 0.75-inch barrel for standard tablets. Double B is a shorter punch standard for high-speed industrial rotary presses. Let's explore the 3 coating machines mentioned in your notes. The standard coating pan rotates a solid copper or stainless steel drum, blowing hot air over tumbling tablets from a spray nozzle. The perforated pan system, like the Acela Coda, improves efficiency by drawing heated air directly through a perforated rotating drum. The fluidized bed coater, using a Worcester column, suspends tablets in high-velocity hot air and sprays them from the bottom. Let's dive deeper into the specific types of coating pans. Standard pans have been modified to improve drying. The Pellegrini pan uses fully automated baffled air. The immersion sword system dips a perforated hollow sword directly into the tumbling tablet bed to introduce hot air. In perforated pans, commercial brands use different air paths. The Acela Coda draws air from top to bottom. The high coater introduces air via hollow perforated mixing baffles. The dry coater channels hot air through grooved perforated ribs inside a solid drum. Now, let's look at the intensive 6-stage sugar coating procedure. First, sealing with shellac protects the core from moisture. Second, subcoating with acacia and dusting powders rounds out the sharp edges. Third, syruping with thick sucrose solutions smooths the tablet body. Fourth, coloring dyes the tablet. Finally, polishing with carnauba wax provides a beautiful, glossy shine. Finally, modern film coating applies a thin polymeric membrane. Formulations use polymers like HPMC for standard protection and plasticizers like polyethylene glycol to prevent film corner cracking. Enteric polymers, such as cellulose acetate phthalate and eudragate, resist stomach acid, dissolving only in the alkaline environment of the small intestine to release the drug safely.